Hi, I am Patricia Yvonne Presbitero and I am going to discuss about fertilization and fertilizers. First, fertilization. So this refers to the addition of fertilizers to soil or water for the maintenance and growth of desirable phytoplankton and other kinds of algae for food of aquatic animals such as the fish. And fertilizer, this refers to the substance that are used for fertilization, and this has two types, mainly the organic and inorganic. First, the organic fertilizers. These can be decomposed and contain varying amounts of nutrients. Example of these are the animal manures, which contain different nutrients, which is shown in the table. So this table is about the average composition of several manures from poultry, sheep, fattened cattle, dairy cows, and pigs. Second, the inorganic fertilizer, so they are not decomposed but rather dissolved in water, and they contain at least one of the three major plant nutrients, which are the nitrogen, phosphorus, and the potassium. Inorganic fertilizers have three types. First, the single element fertilizer, so it contains only one fertilizer element out of the three. The second is the incomplete fertilizers, which contain at least two fertilizer elements. And the third is the complete fertilizer, which contain the three major nutrients. So this table on the right provides some common fertilizers used, both organic and inorganic, in their analysis of grade, which will be used later for the computation regarding the fertilizers. Determination of amounts of fertilizer nutrients and of the required absolute amounts of fertilizer. So there are two different formulas in determining the amount of both fertilizer and fertilizer nutrients needed. So first, the weight of the fertilizer in kilogram is equal to the recommended treatment or dosage of nutrient in kilogram over percent of fertilizer nutrient available for use times 100, and there's also a formula if the unit is in bags. And the second formula is the weight of the nutrients available is equal to the weight of fertilizers times the percent of fertilizer nutrient available for use in decimal. So for example, these are the given. The recommended dosage is 30 nitrogen, 20 phosphorus, and 0 potassium, and the available fertilizers are urea, which has the grade analysis of 46 nitrogen, 0 phosphorus, and 0 potassium, and for ammonium phosphate, it has a grade analysis of 60 nitrogen, 20 phosphorus, and 0 potassium. So first, the question is how much of these given fertilizers are needed in order to meet the requirement or the recommended dosage. So there are things to consider in solving for the fertilizer and fertilizer nutrients needed. First, we should solve first the nutrient of the recommended dosage that has the smallest amount to satisfy it first. And second, we should use the fertilizer that has more nutrients to solve for the weight of fertilizer needed. So in this example, we are going to solve for the phosphorus and ammonium phosphate first. 20 kilograms of phosphorus divided by 20% of phosphorus times 100, so the weight of the fertilizer is 100 kilograms. So let's move on with the weight of the nutrients available. The formula is weight of fertilizers times the percent of fertilizer nutrient available for use, which is in decimal. So let us use the initially computed weight of fertilizer, which is the 100 kilogram times 0.16 nitrogen of ammonium phosphate. And the answer is 16 kilogram nitrogen. We should also compute for the weight of the phosphorus available, so that is 100 kilograms times 0.20 phosphorus of ammonium phosphate. The answer is 20 kilogram phosphorus. Since we already computed all the fertilizer nutrients, let us see if all are satisfied by subtracting from the recommended dosage. So the recommended dosage is 30 nitrogen, 20 phosphorus, and 0 potassium minus 16 nitrogen, 20 phosphorus, and 0 potassium, and that is 40 nitrogen, 20 phosphorus, and 0 potassium. Only the phosphorus and potassium are satisfied, so let us solve the weight of the fertilizer through the nitrogen. So again, the formula is the weight of fertilizer in kilogram is equal to the recommended treatment or dosage of nutrient over percent of fertilizer nutrient available for use times 100, and that is 14 kilogram of nitrogen over 46% nitrogen from urea times 100, and the answer is 30.43 kilograms. After that, let's add both of the computed weight of the fertilizers, so that is 30.43 kilograms plus 100 kilograms. The total is 130.43 kilograms, so this is now the needed amount in order to meet the recommended dosage. Determination of amount of fertilizer to be applied using a ratio and proportion formula or the cross multiplication technique. So the problem is, the standard amount or rate of fertilizer application is 50 kilograms per hectare of 60 nitrogen, 20 phosphorus, and 0 potassium. How much amount of the same fertilizer is needed if the area to be fertilized is only 3,500 square meters? So the given for this problem are, first, the standard amount or rate of fertilizer application, which is 50 kilograms per hectare, and the second is the area to be fertilized is 3,500 square meters. So what is asked in the problem is the amount of fertilizer. So to compute, 50 kilograms per 1 hectare times 1 hectare over 10,000 square meters times 3,500 square meters divided by the amount of fertilizer, and that is 17.5 kilograms of 16 nitrogen, 20 phosphorus, and 0 potassium. Determination of the amounts of fertilizer needed to apply when the treatment or dosage is in ppm or parts per million. The sample problem is how much amount of 6 nitrogen, 20 phosphorus, and 0 potassium will be needed in a 1 hectare or 10,000 square meters pond having a water depth of 1 meter and requiring a treatment or dosage of 5 parts per million. So these are the given. First, the area of 10,000 square meters. Second, the water depth of 1 meter. Third, the dosage required, which is 5 parts per million or grams per cubic meters. And what is asked in the problem is the amount of fertilizer. So the formula would be amount of fertilizer is equal to volume of water times dosage of fertilizer in parts per million. So for the volume of water, we have to solve first, and that is the area, which is 10,000 square meters times 1 meter, which is the water depth, and that is 10,000 cubic meters. So for the amount of fertilizer, volume of water, which is a 10,000 cubic meters times the 5 parts per million or grams per cubic meter, and that is 50,000 grams or 50 kilograms of 60 nitrogen, 20 phosphorus, and 0 potassium. Determination of the dosage of fertilizer in parts per million when the amount of fertilizer to be applied and the volume of water are given. So the formula is dosage of application in parts per million is equal to the amount of fertilizer to be applied in grams divided by the actual volume of water. As for the given, that is 50,000 grams divided by 10,000 cubic meters is equal to 5 grams per cubic meter or 5 parts per million. Determination of the equivalence of amount of inorganic fertilizer to animal manure basing on one of the NPK content, say phosphorus only or nitrogen only of the fertilizer. So the sample problem is, if 1 hectare pond would require 50 kilograms of inorganic fertilizer having a phosphorus content of 20%, how many kilograms of organic fertilizer containing 0.41% phosphorus would be needed as equivalents of the former fertilizer in terms of phosphorus content? So for the step 1, this is to determine the amount of phosphorus in 50 kilograms inorganic fertilizer. So the formula would be weight of the nutrients available is equal to weight of fertilizers times percent of fertilizer nutrient available for use, which is in decimal. So that is 50 kilograms times 0.20 phosphorus, and that is 10 kilograms. The second step would be in algebraic expression to determine the amount of the animal manure. So to find the weight of the fertilizer, we're just going to divide the weight of the nutrients available by the percent of fertilizer nutrient available for use in decimal. So that is 10 kilograms of phosphorus divided by 0.0041 of phosphorus. So the weight of the fertilizer is 2,439 kilograms. Determination of the exact rate of organic or manure fertilizer application with a consideration of the following. First, the organic matter of the soil. Second, the organic matter of the manure. And the third, the depth of the surface soil that benefits from fertilization. So for the given, first, the weight of the 2 centimeter depth of surface soil in an area to be fertilized, which is 200 tons. Second, the original organic matter content of the subject pond soil, which is 7%. Third is the organic matter content of the poultry manure, which is 40%. And last, the desired organic matter content of the subject pond soil, which is 8%. So to compute for the amount of animal manure, we just have to substitute the values in the formula. So as for this example, the answer is 6.25 tons per hectare. Common practice on rate of fertilizer application. Without soil analysis, these are the recommended application rates on chicken manure or organic fertilization. First, the 3,000 to 4,000 kilograms per hectare in combination with 50 kilograms per hectare urea. This is to enhance the mineralization process. The second is 1,000 to 2,000 kilograms per hectare in combination with 50 kilograms urea. This is for old and loamy to clay ponds as basal fertilization. And the third is 1,000 to 2,000 kilograms per hectare without urea. This is applied every 2 weeks until 30 days before the harvest for the maintenance and growth of the lablab. For inorganic fertilization without soil analysis, the recommended application rates are the 50 kilograms per hectare of incomplete inorganic fertilizer 1620 NPK for salty water, or the complete inorganic fertilizer of 14-14-14 NPK for fresh water as basal fertilization. And the second is the 8 kilograms of nitrogen and 10 kilograms of phosphorus per hectare, which is equivalent to 50 kilograms per hectare of 1620 NPK, or the incomplete fertilizer. This is to be applied every 2 weeks until 2 weeks before the harvest. This is to maintain the growth and the maintenance of the phytoplanktons as natural fish food. For the methods of fertilizer application, 1/3 to 1/2 of the total amount of fertilizer is dissolved in a pail of water, and the fertilizer in solution will be spread all over the pond surface, and the rest will be wrapped in a cloth, and then it will be hung on the stakes or be placed on a pre-installed platform in the pond for gradual dissolution. Do's and don'ts in fish pond fertilization. For inorganic fertilization, this should not be applied during heavy, cloudy, or rainy hours or days. It should be applied on a sunny day between 9 a.m. to 12 noon for fast assimilation by plant organisms. And for organic fertilization, the organic fertilizer should not be spread immediately all over the pond surface. Instead, they're soaked first with the container bag and then released in certain parts of the pond.
Next is the propagation of lablab, or its process of fertilization. So if your pond is new and it has yet to be flooded, apply chicken manure by spreading evenly over the pond bottom at a rate of 1,000 to 2,000 kg per hectare and 500 to 1,500 kg per hectare for ponds that have been in use for over 5 years. Next is admit the water to a depth of about 3 to 5 centimeters and apply 50 kg per hectare of urea to hasten the composition of the manure, and then allow the pond to dry for at least 3 days. Next is readmit the water to an average depth of 8 to 10 centimeters and then apply ammonium phosphate fertilizer at 500 kilograms per hectare or diammonium phosphate at 50 kilograms per hectare by spreading evenly over the pond bottom the next day. Next is admit an additional 5 centimeter depth of water every 3 days until it reaches to about 20 centimeter level, and then apply ammonium phosphate at 15 kilograms per hectare again every 7 days, but no less than 3 days before the stocking of fish. So you stop the fertilization process 3 days before putting the fish onto the pond. 3 days before stocking, gradually drain 25% of water and refill to the desired level of 20 to 30 centimeters, 20 to 40 centimeters, and 50 to 60 centimeters. Admit water gradually to avoid the disturbance of the growth of the lablab since it's already rising on the surface of the pond by then. Then stock the fish on the 28th to 35th day from the time of spreading the manure depending on the thickness of the lablab, which should be about around 1 centimeter already, and then maintain a luxuriant growth of lablab and apply a side dressing of 15 kilograms per hectare of ammonium phosphate every 2 weeks during the rearing period, and then stop the fertilization process 20 days before harvesting the fish. So next we'll be talking about the production of plankton or the process of fertilization of it. So unlike in lumot, when producing planktons, we need the pond to have water already. So first, fill the pond with water to a depth of at least 60 centimeters, but preferably 75 to 100 centimeters. Next, apply 1 to 2 tons per hectare of chicken manure contained in bags by soaking them first in the pond for at least 24 hours before finally releasing them. Add 50 kilograms per hectare of urea after the manure had settled down. The organic fertilization, along with the urea, which serves to hasten the decomposition of manure, could also be done before the admission of water into the pond. Next, apply ammonium phosphate at 50 kilograms per hectare or 22 kilograms per hectare of diammonium phosphate 1 week after the first fertilization application. One half of this amount will be dissolved in a pail of water and spread over the pond water surface. The other half will be put in a thin cloth bag or any substitute and then hung strategically on a stake positioned in the pond for gradual release of fertilizer nutrients. Next, observe the productivity of the plankton for the next 7 days through the green to yellowish green turbidity of water. Visibility during this period is read using a device called the Secchi disc. It is ideal that at 30 to 40 centimeter below water surface. Observe the productivity of plankton for the next 7 days to the green to yellowish green turbidity of water. Visibility reading using a device called Secchi disc is ideal at 30 to 40 centimeters below water surface. Turbidity above this range indicates low plankton productivity and signals further or additional fertilization. Fish stocking shall be done 2 weeks or so after filling the water, during which time plankton growth should be about 30 to 40 centimeters Secchi disc level. Lastly, apply 50 kilograms per hectare of ammonium phosphate or 20 kilograms per hectare of diammonium phosphate every 2 weeks, plus 1,000 kilograms per hectare of chicken manure every month thereafter to maintain the abundance of plankton. Again, stop the fertilization 20 days before harvesting the stock. Lastly is the growing of lumot. The fertilization process of growing lumot is the same as the fertilization process of lablab, and this grows favorably in lower salinities and a water depth of 20 to 60 centimeters. Lumot occurs naturally, but seeding may be resorted to when growth is very sparse. Fibrous or the silky filaments are best type of life stage of lumot for seeding or planting purposes. These are planted either by staking, sowing, or spreading, and the luxurious growth of lumot is not entirely desirable because this plant and the fish stock will compete for living space.